Okay, so just over the halfway mark, question number 8. Um, Hopefully it's been going good for you so far. I do try and talk around things a wee bit. Obviously, this is a 1 hour paper. These questions was there 14 questions. You know, you're looking at spending about 5 minutes each ish. There's that kind of number. So obviously these videos are a bit longer than what you would want to spend on each question, but I do try and talk around everything. So I suppose the video shows you've got time to think. You've got 5 minutes a question, which actually, well, roughly 5 minutes a question, which doesn't, pardon me, doesn't sound like a lot, but some of the questions are very quick. I mean, you saw here actually, I was talking for ages on this question, but really, it doesn't take 2 seconds to put these numbers in. So yeah, take your time, think, don't just rush through. But yeah, it's you've got 1 hour, you can't spend too long on things. Um, and also, yeah, I like to chat, so you have to go faster than what I'm going anyway. I think what I'm trying to say. Anyway, right, question 8. Find the equation of the line joining these points. Okay, now there's 2 ways to go about this. I'm going to show you both of them because I think it's quite important. Minus 2, 5. Okay, so we're going to go minus 2 left and up 5. Okay, so I'm going to say that's about here. Okay, and then 3, 15. Go over 3, up 15. I'm going to say it's there. Okay, so that's my line. I'm going to call that point A and point B, or point 1 and point 2, whatever you want to call it, right? So you should look at that and think that's positive. If the line's going in this direction, it's positive. Okay, so all these lines here, they would all be positive. Maybe not, maybe not that line. Don't know what that line's doing, but everything like this, okay, they're all positive lines. All right. All these lines would be, oops, all these lines would be negative. Okay, negative lines. Yeah. Okay. So I know my gradient's going to be positive. Now there's 2 ways to work out the gradient. Okay, now because we're doing coordinates, I'm just going to show you the coordinate method. In fact, no, I'm going to start off with the equation. Okay, so we know the equation of a straight line is y is equal to mx plus c, which is the equation they're trying to get us to do. And the first thing we always work out is the gradient. Okay, let's put in here the m. Right? Now m, we should know is equal to y2 minus y1 divided by x2 minus x1. Okay, so you can pick either point, doesn't matter which. I'm going to pick this point as point 2. Okay, so the y2 there is 15. So it's 15 minus 5 divided by 3 minus minus 2. So that's 10 divided by 5, which is 2, plus 2. Okay, which is what I expected. Well, I expected positive anyway. Okay, so that's the easiest way of doing your m value. But just because we've been given coordinates, I'm just going to think about what that actually means, right? We're looking at the difference between, y2 minus y1 is basically the height that is travelled, and x2 minus x1 is the length. Okay, now you can look at it like this. If I do a line here, okay, this is how much it's travelled vertically, isn't it? It's gone 15 is how far it's ended up, but it started on 5. So what's the difference between them? Well, that's 10. So that means this distance in here is 10. Okay. And then for the x terms, well, what is that? Well, we started on minus 2, we ended up at 3. So it means that this distance in here is going to be 5. Okay, so the gradient is just the difference in height divided by difference in length. Okay, so that's 10, that's your 10 over 5 right there. So when you look at these numbers, you can sometimes just guess roughly what you're gonna, roughly what the gradient number is gonna be. Okay, so relative to that, I did think it was gonna be about 1 or 2. It wasn't gonna be a massive number. It's it's travelled 550, 515. Like, okay, that's not a lot. Sorry, 5 and 10. So I knew it was gonna be a small gradient. Okay? But you could literally draw it like that, and just say 10 divided by 5. You don't need to actually do this equation. If you were to show this working, that'd be sufficient, I think. All right. So that's 2 ways to work out the gradient. You don't have to use this equation, but this is what the equation is saying. So it's the difference in height divided by difference in length. So 10 divided by 5. Okay. So now we know that y is equal to 2x plus c. Okay. Now this line gives us lots and lots of y and x values, but we only know these 2 of them. Okay, but obviously any point on the line has got a y and an x value, doesn't it? Okay, so let's substitute in what we know. We know a y and an x value, and that'll let us work out c. Okay, so I'm just going to pick the 3 and 15, so there's no negatives. Okay, so I know that 15, that's y, is equal to 2 times 3 plus c. So 15 is equal to 6 plus c. And I know that 9 plus 6 gives me 15, so I know c is equal to 9. So then y is equal to 2x plus 9. Okay, that should be pretty straightforward. If this bit is difficult for you, that's fine. What I did here was, I said, well, I want to move 6 onto this side to get c on its own. So I've got plus 6. How do I move a plus 6 over? Well, I take away 6 from both sides. So it becomes 15 minus 6 on this side, 15 minus 6. And on this side, it just becomes plus 6 minus 6, which is 0. So that's c. Okay, so 15 minus 6 is going to give me 9. And then on this side, we're just going to end up with c, which is why we got the 9c. Okay, so we bit messy there, but we did go through this. If you want to do more of the rearranging, I think what question was it? Yeah, the inequalities is quite similar. I kind of chatted through some of it in question 2. All right, but obviously you're just changing sign, doing the opposite. You're doing the opposite operation to move it from one side to the other. Okay, but it's quite obvious that 9 plus 6 gives us 15. Okay, but mathematically what I did was I said, well, to get rid of plus 6, I'm going to take away 6 from both sides, so it cancels on this side. 15 minus 6 gives me 9. C is 9. Okay, and don't forget to write your equation at the end. Okay, so you're getting a mark for your gradient. 10 over 5 is just 2. A lot of people use the other equation, the y minus b is equal to x minus a. And at that point, I think that's where the simplification comes in for the question, because actually doing this method, there wasn't really any simplification. Maybe if you left it as 10 over 5, you might have dropped a mark actually. But yeah, you get a mark for your gradient. You're then going to get a mark for working out c, and then a mark for stating the equation in terms of y and x. Okay, so pretty straightforward. But I don't think I've done that before in the videos, because yeah, I've just not done it before. But that's one way of thinking about what the gradient is. How am I doing for time? Fine. Write the following in an order of size, starting with the smallest. That's actually that's a great question. That's a great question. So again, if you're thinking, I have no idea, mate, no clue, just try and work out what each of these is, okay? And you might get something, okay? So let's have a think. How do I start this? Let's think of our cost graph, I think. Right. So there's 1, and there's minus 1. And I know that is 180. So let's try and put our points, okay? Let's say let's call that point 1, point 2, and point 3, okay? So where is cost 90? Well, we should know that cost 90 is actually this point here. Okay, so we know that is 0. Okay, so we'll just say cost of 90 is equal to 0. Right. Cost of 100, well, cost of 100 is going to be in here somewhere, isn't it? I don't know exactly where. It's going to be in there-ish. I don't know the value. And cost of 300, well, 360 is the whole lot. But 300 is probably going to be in here somewhere. Okay. Now, write the following in order of size. Now, without actually working anything out, okay, you should just from looking at that graph be able to say, well, I'll tell you what, cost of 300, that's the biggest, because it's going to be, it's positive basically. Cost of 90 is 0, and then cost of 100 is negative. So I'll be writing, kind of positive, 0, negative. Okay. Sorry, yeah, it does. So it does say justify. It does say justify your answer. So sorry, the first bit. If it just said write it in order, then there you go. If I was looking for a justification, this to me would be my justification. Okay. You could obviously try and work out the numbers from. Could you work out hundreds of that? I don't think you could work out cost of 100 as a value, But actually, cost of 300 you could, because if you think of your quadrants, you know, yeah. So in this quadrant here, you know that's actually the same as 60 degrees, isn't it? So you know what the value of cos of 300 is, okay? Cos of 100 would be in this. Yeah, you could work that out. So cos of, well, maybe not. Cos of 100 would be in here. So that'd be the same as 80 degrees. I don't have a value for that. But you could do your exact value for the 60 though. So we know cos of 90 from here is 0. We can't do 100 because there's not an exact value for 80. But for 300, if it's in this quadrant, that's going to be the same as 60 degrees. Okay, so this is where you get into your triangles for exact values. So you don't need this, right? I'm just telling you it's a bit of extra. This is what we've written here is totally sufficient. Okay, and you're getting a mark for this part in here, and you're getting a mark for this bit in here. So I think if they saw the graph, saw the points in this, that'd be perfect justification. Okay, but I'm just giving you this as a wee bit of an extra, right? So don't forget your exact values, and I would always draw a triangle out. So this would be a 1, 1, root 2 triangle, and that's 45 degrees, and that's 45 degrees. Okay, so that's one of my exact values. So I know that, sine of 45 opposite over hypotenuse is 1 over root 2. Okay, I know cos of 45 adjacent over hypotenuse is 1 over root 2. Okay, tan opposite over adjacent is tan of 45 is then 1 over 1, just 1. Okay, so that's one of them. The other one is this one. Second. In fact, you know what? I've drawn that just round. It doesn't really matter what way you draw it, but actually just to be, consistent with um, what I usually do. Sorry, root 3, 1, 2. So sorry, root 3. So the only thing is for the 60-30 triangle, the root 3 sits next to your 30 degrees. That's the way I kind of remember it. Okay, so it doesn't matter what way around you draw it. But as long as the root 3 is next to that. So with Pythagoras, we know root 3 squared plus 1 squared is going to give us this number squared. So 3 plus 1 gives us 4. All right. But these two, you could then work out what cos of 60 is. So cos of 60 is your adjacent over hypotenuse. So cos 60 would actually be a half. Okay. So we know this one is going to be 0.5. So actually it should be a wee bit further down, just in there. All right. So yeah, that's they could have tested, they maybe could have tested you on that, but they were just looking for more kind of common sense with where numbers sit on the graph. So we bit of problem solver in that, but you're still getting a mark for just for just thinking, well, where do they sit in the graph? But maybe people couldn't put into words, the justification. But I don't think it's that highly difficult question. But remember, in these come in handy. Your little exact values. Okay, 1 root 2. The 45 one's a dead easy one to remember. Of this one, it's easy to kind of get muddled up between your 60 and your 30. But if you just think of the root 3 sits next to 30, okay, um, that's maybe the only thing I can think of actually. So yeah, equation of a straight line, y is equal to mx plus c. That's one I prefer. C obviously, or maybe we talk about m being the gradient, but c is the point at which this graph crosses the y-axis. Okay, so the question said, well, at what coordinate does this line cross the y-axis? We would say, well, at 0, 9. Okay, and that kind of makes sense, doesn't it? Because if it's 5 here and 15, it's not quite in the middle. So yeah, you're kind of like, okay, 9. Yeah, I can live with that. If you got something less than 5 or bigger than 15, there'd be an issue. But you can see it's obviously clearly a number between 5 and 15. Probably going to be around about 10. It's kind of in the middle, right? So yep, equation of a line, and then here we just talked about the a little bit about your CAST diagram, or all smokers take cancer, as I sometimes say, where these numbers sit, and I just gave a bit of extra information on exact values. So yeah, cos of 300 is biggest because that's positive. Cos of 90 is 0, just sits in there, so that's 80. So that's 90, 180, 270 in there. And yeah, cos of 100 is going to be negative, so obviously be the smallest number. All right, good stuff.